All right, I try to give you a couple of glimpses for how we start, because you're starting, maybe you are interested how we started. So how we started was like, we had the 2009 we had the first course under my supervision. The spaceflight instrumentation was the course. There was a lot of nice guys and girls participating, and really important people also sort of lecturing this course. And then we had several like guys and girls who are nowadays in Finnish space business. And this was 2010 when we started to make a mission study about a first Finnish satellite. That was one of the first pictures we rendered, or I rendered actually this one. And then we met with another team in Finland who has been like already thinking about the satellite, but they didn't have anything concrete. Basically what we did was a feasibility study which had this satellite drawing, which was pretty much the satellite we actually ended up building. It had an S-band, it had a VTT spectrometer camera, it had this radiation monitoring system. They had a couple of more things there as well, but this was the first sort of block diagram. And you don't need to actually go any deeper. That's okay. If you have a good idea what you want to do, then this will be all right. So we were, of course, telling like we are building satellites. This is one of the first TV presences we had. So there was a TV show that said like, wow, we heard that students are starting to build satellites in Finland. And then they had some sort of funny, this was the satellite project here they were making, and we had to have the lab coats and everything. But actually, we didn't have much sort of, our first table we started was like, this was our lab. We didn't have much. But we had actually entire lab for other things than space technology. So that helped a lot. And one of our first presences in media was when Tim Kopra from United States, his grandfather and grandparents, I think all the grandparents actually, are from Finland. So he was visiting Finland, it was summer, nothing to do. He was like meeting with the president of Finland. And then they said like, called me like, Jaan, do you have anything space happening? Because we have this astronaut here and nobody's here anywhere, and we need to do some kind of program. Maybe he can meet with students. They said like, yeah, we have students and they are starting to build a satellite. And then this how we got the first media presence in Länsiväylä, which is a very local, small newspaper here. Then we had the first summer school. The summer schools and all these things has been like really seminal sort of for this thing, because people in Estonia, they were already building satellites. And then with Estonians, we were making a lot of summer schools and things. Our first satellite was actually cardboard satellite. So this is the Aalto one first model ever built. And yeah, let's see. This was our first budget, which actually ended up to be pretty spot on, because we were, it was like very short. We actually launched 2017, not 13, but the amount of money we were spending was approximately like this.
The launch was cheaper.
Yeah, launch was cheaper, yes. So we started to build the satellite. So this was the first mock-up satellite we built. I bought a lot of pizza to the lab, and then we had the first team who built this aluminium scrap, electronic scrap made satellite. And as you can see, actually, it has all the same elements already, like S-band antenna is approximately the same place. We had already like this two-stack system, which actually appeared in the Aalto one and so on. The point is, the early on decisions are going to affect a lot for you, like your later mission. We had really young guys eating pizza, like messing around it. This is Rafał Modrzewski, CEO of ISAR. So in the lab building the satellite there. We didn't have much about information about how to build satellites, how to test satellites. So these are like some of the early images. We had a lot of seminars. So we had a lot of seminars where we were trying to think what to do, how to do, learn from others. And also, this is another campaign. We were building the ground station on the roof. This ground station actually was never used because we moved from this building to another building before the launch actually happened.
Is it still there?
It's not there actually, yeah. And then we made a lot of outreach, different kind of photos. Maybe they are fun. I will show you some of the summer schools in Estonia, lab shoots with like setup labs which have nothing to do with space. Some photos here and there. First conferences. This is the Berlin Small Satellite Conference. No, this is not. This was the Berlin conference. This is the summer school in Estonia. Are you? Okay, onko teillä varma?
Joo, tässä on
Okay, so we have to leave. Signed into the Sherpa launch, which was one of the first CubeSat launches with SpaceX sort of specific small satellite launch. And it was like delayed, I think finally like 4 years or something like this. So we bought the launch from ISIS Space and they said, yeah, Sherpa launch, it's coming, you're going. And it was not happening at all. And then finally they rescheduled us to PSLV. And we got a launch for 2017 midsummer, which was a catastrophe in PR sense because nobody in Finland is going anywhere from their cottage during the midsummer. So we were not getting much of the PR out of the launch, but nevertheless it went. And these two satellites, Raptor Hello World, which is our spin-off, and ISAR, which is also our spin-off, they were already ready with their own satellites. They were like first developing with us, then like having their own projects, and then like starting companies, making their company first satellite was taking approximately the same time we are getting like our satellite launched. But nevertheless, it was lucky enough, so we were the first, second was ISAR, and then the third was Raptor Hello World, but they were all neck to neck, and we didn't know which one is going to be the first in a Finnish history. So it was sort of close call there. Right. Then I will talk a bit about lessons learned. And how we build the satellites. I don't know how much you have been already going through, but a couple of not very well organized thoughts. What we do here and what we did with the student satellite, we were arranging the teams according to clear hardware units. So we have a onboard computer team, radio team, solar panel team, payloads, they were made outside. In order to make this kind of, it's good to keep the same interface sort of everywhere. For example, if you have an EPS team, then so this is part of the EPS, but because it's a separate unit, you just like give it to the other team. A lot of stuff what you need to do between the teams is interface definitions. So a lot of stuff needs to be just like somebody somewhere needs to draw these block diagrams, how things are related, and what are the relations between, what are the interfaces. So we have been taking time to make these kind of block diagrams of everything, including the drawings and things. And we have a big, and we have been developing all our four satellites now with having a big spreadsheet, which is having all the design parameters, including mechanical interfaces, pin layouts, mass budgets, link budgets, power budgets. Everything is in one big spreadsheet, which is online all the time. So this is what we do. And this helps to keep the numbers sort of current, that you are not having any different versions. I just have one spreadsheet. If you go there, you see like what is the pin layout at the moment. And nobody, also in Google, what you can do is like you protect your sheets. Only the systems engineer can change it. So people can see it, can do the stuff, but they cannot mess it up. And
commenting is also nice. If you give it out for review, you have already the commenting function built into Google.
And we have been like using quite a bit of time of like, or shaping this documentation style so that we keep everything open. Everybody can go and edit documents if they need. They have some of the areas which are off limits, and then we are using the same things in different documents. So you just like copy it, it propagates to all the other documents, the right version, and then you don't have any versioning. So we actually don't have a versioning in our documents. They are just like one set of online documents. If it's outdated, it's outdated. So you have to ask guys and so on. Hardware model philosophy. This is what we do. We build prototypes, but we have prototypes are forming the flat set at some point. And at the same time with the electronics prototypes, we are making the structure prototype, which is going to the structure model. So we are developing the sort of the satellite electronics at the same time when we are making the mechanical model. And we go to the mechanical model to the tests pretty early on, when the actual like flat set is still sort of flat set, and it's not like any final shape. In order to get all these mechanical interfaces frozen before we start to integrate with electronics, because you cannot like take it out anymore afterwards. And if your structure is not working and you have been designing all the electronics according to the structure you had, and then you have all the holes in the wrong places and connectors in the wrong places, then you have to redesign everything. So that's why we sort of make this parallel lines. And then we try to have a proto-flight model philosophy, that we only build one satellite, it's for qualification, and then you will just improve it a bit and then make it a flight model. We gave up pretty fast, because it's not very material expensive to build engineering model, which you like develop and do all the stuff, and then you build the flight model and actually flight spare as well. However, what we do is we build many models and try to improve them even between. In a classical space, you are not doing anything in between here. You just like test it, everything should work, and then you build the flight model. We test it, many things break, we rebuild, we improve, we do new stuff, and then we do the flight model. And sort of like we have this incremental thing. It's like the whole thing is, this kind of philosophies are, it's really simple, sort of. Like we have just this kind of simple diagrams. This is how we do schedules. It's sort of like very simplified schedule that you try to see like what is happening. And it's not necessarily really good way of doing, but project management with students is one of the pain points. Because like having students deliver the stuff, but they have been like committed in the time you want to have it. Having all this specific knowledge or specific skills when you need it in the project, it's really, really tricky. So you sort of need to have it sort of pretty simple because people come and go. Couple of words more about the documentation. So documentation is the communication tool, and you shouldn't use documentation as a goal, but you are writing the documentation in order to communicate something to somebody. You don't make the documentation in order to have the documentation. And if the project is growing, the documentation is getting more and more important. If you are doing the small project with like 3 guys, you can actually do it better with a whiteboard if you don't wipe it in between. Sort of like the information is going through, staying in the lab, and you can make it very, very fast. Everybody can ask everything, and you like put your numbers down and everything is sort of everybody up to stay. But when the project is growing and you're going to have like people leaving the project and entering the project, then you need to have documentation. You need to have some kind of way how to pass this information, what has been done, what is not done, and so on. And it's like a lot of time actually goes to the communication to the other people inside the project. Documentation helps a bit, but it actually is not covering all these parts with the whiteboards and everything. You still need to have it quite a bit. And our experience is also, or my experience also tells that in this kind of project, the information and the community is living in a certain space. You need to have your own corner. If you don't have a corner for your project is struggling without having any identity or getting together, getting the information somewhere stored. People are not like getting attached to the project if they don't have a place to come to. So if it's possible to find a corner and dedicate it to this project, I think it will help. Project management. I have a lot of pictures here, but let's see. If you can afford a project manager, would be perfect. But we have been managing all our projects without a dedicated project manager. Regular meetings, regular deadlines. The problem, if you have a bigger project with more partners, it will automatically extend your schedule. Because like everything starts to get slacks in between the schedules and the things are not agile anymore. So we were also in the beginning like building absolutely crazily complicated project. Aalto 1 satellite had 3 different payloads from the 3 different partners. It's absolutely unnecessary for having a satellite project with all these payloads, and having all these like 3 different payload teams with their own funding issues, with their own schedule issues, delivery issues, review issues. It was totally crazy. Absolutely not recommended. What you also need to have, what I'm pointing here out, is the procurement system. If you have this kind of project, you need to create a procurement system. So people are knowing how we buy things, and not everybody needs to know about everything, but we, for example, we procure a lot. We have a constant flow of PCB orders, of component orders, of material orders, and it needs to be some kind of system which is like taking these and like bringing it back to the lab. In the beginning we didn't have it, and it was a big mess. Who has right to use money, how much money can be used, and so on and so on. So we were using a lot of unnecessary time for just arranging the procurement. If you can make a sort of branch who is just working with procurements, would be good. model philosophy, we were talking, let's see, I have some documentation things. Okay, we have Google Docs, we don't use Dropbox anymore. We have GitHub and Google Docs. Sort of works. It's still maybe a bit too like paper documentation centric. Would be nice to have like totally model-based documentation when you just like I think many student teams are using wiki-based systems and they are working pretty nicely, but they are sort of more clunky to edit. And the good thing about Google Docs is that whoever comes to your computer, they feel like they can edit this document. It's like the threshold for editing anything is really small. And commenting is easy, it's like pretty beautiful and visual right away, and so on. But when we try to do things sort of in a modular way, that we have all the drawings and tables and everything is also like self-standing documents. Sort of you have a table and this is already a document. You don't need anything around it. So you don't have to like have all the headers and things and page numbers and whatnot. If you need to have a table, make a table, call it the document, and we just like refer to it later on. And you can embed it later on to other documents if needed and so on. So we try to keep it sort of modular. Having this documentation, these are sort of ideas and good ideas, but implementation is always a bit more hairy than this. But I think it's a good thing to keep in mind. And you don't need to have like proper document on everything. So we have sort of, yeah, maybe we don't talk about this one. About harness and stuff. Build prototypes. I mean, this is from any kind of thing. Build prototypes, start building the thing. And what we were finding out, for example, in like a CAD program, people were like building beautiful things, electronic people were building beautiful things. Then we were starting to put together and, okay, it seems like we have the connector on the edge, but nobody has been thinking that the connector has also the counterpart. So this is not fitting into the satellite now, and everything is sort of done. And these things just pop up. Another thing with like prototypes is that you are having the people on the CAD designing everything, and then you start to assemble it, and then it's just like, how can I assemble it? I need to have like 4 hands. You need to have this. You have to hold those here, and then you have to put it from under here, and it's not working. So building the prototypes, 3D printers is really good approach to like do the prototypes, building these things. So with Aalto One, we were building really ugly stuff, like starting with the cardboard models and going with like really ugly things and prototypes, till we finally sort of got something which can be assembled. And for assembling the final part of this one, we still needed like 4 hands, because it was like sort of stupidly designed, because you couldn't like put the last part into the system without having 4 hands. Do I have meetings also? Probably I don't have the meetings here, but one of the things which usually the student projects are doing is you have a lot of meetings, and you start trying to make also the meeting protocols and make your decisions written somewhere and so on. And then you come back, everybody are coming to the meeting, nothing much has been happening, but you again discuss things and make decisions and sort of document them and so on. We were at some point abandoning this thing, because it was like making all this documentation about the meetings was sort of useless, because people are not having enough information to make the decision. Nevertheless, they will make the decision, they will write it down, and then later on there is a huge web of decisions which have no value. So what we do nowadays instead is we try to keep everything in Trello, and I think it has a good let's say, philosophy. It doesn't work perfectly as well, but this is our Trello for the developments. So in the meeting, you should just go through like what is happening now. And if you have this visual system of Trello, for example, you can
be also done in GitHub.
Yeah, it can be different kind of Kanban systems are around. It doesn't need to be Trello.
Would you recommend using GitHub?
But
Would you
how
recommend
it works
Trello?
is that you have a visual overview. What is happening right now? You concentrate only on the urgent things. If you do some kind of decision of something which is like high priority, TVAC test plan, so you can actually write here, is this done or not? It's done, documented, that's it, one click. And you have the whole system, because having a sort of linear documentation doesn't give you the overview where we are. This one gives you some kind of overview. So you're not like wasting your time on the decisions. And although decisions are important.
Can you unmark that, please?
Yeah, it's not done.
Thank you.
So you actually have one place where the whole status of the project is given. And another thing with this one is like, we have been trying different kind of task management things. And the task management with students is difficult because some students are keeping up their tasks and some students are not. So if you have a project manager or even somebody who is updating this during the meeting, you can manage this without the student participation as well. You have somebody here, you have, I don't know, Topi or Marius or somebody who is doing this thing, and you're saying like, okay, I'm assigning this to you, and next time I'm coming, let's say, okay, Topi, that was your task. What's happening? And the all things which are sort of there are sort of keeping ghosting you until they are done. And this was really important when we were having like tens of people in the system, because you are totally forgetting like what was assigned to them, what they are doing. They were not coming here back to like mark things, and then it sort of helped still to keep the system up to date, sort of understanding what is happening there.
Maybe what you see also there in the second column is make smaller goals, like milestones, whatever you call them. Doesn't matter, but that are also reachable, because it gives you dopamine again. It's just nature, and this sort of, you see also the achievements that you have done over whatever time space you look at. So.
Yes, and instead of the of decisions in the meeting, try to make prototypes. So I was really glad looking at your slides that you are actually building something, you're doing something, because this is what matters. And I'm also measuring the progress of the project by how many hours in week we have lights on in the lab. Because if the lights are not on in the lab, then nothing is happening. The actual thing is not proceeding anywhere. We can have the meetings, we can have the presentations, we can draw diagrams, but nothing is not getting anywhere. So that's why it's really, really important to like get whatever minimal viable products out of your line and getting further with this one. Commercial subsystems. So we have been working with the commercial subsystems, and luckily the commercial system has been like developing a lot nowadays. They are so good and so much better, but we have had cleanliness problems. Delivery schedules were really sketchy, and the biggest problem with our commercial subsystem was like getting information about the software, about the features, about bugs is really, really, really difficult. So they are coming like black boxes, and you are usually not able to update anything. If there is a sort of last minute thing and you have a bug, an annoying thing on the bus, which is like doing something which it shouldn't do, then finding this out what it is might take like half a year or more, and endless communication on email and like calling and so on and so on. This is really annoying, and I don't know how to get rid of it, but yeah. On the other side, having a commercial system like speeds up the project. So if you have a commercial subsystems or commercial satellite, then it would be better to like buy or procure as complete satellite as possible. Because if you have almost everything from the same provider, they have been like ironing out the problems. There was a wave of CubeSats where you have like radio from one provider and EPS from another provider, and there is always compatibility issues, and they are not like never working properly.
Maybe one provider that across the board I have heard is like from anyone, especially for the ADCS systems, PayBlue. Not PayBlue. How's the
Blue Canyon.
Blue Canyon? Thank you. I don't know. Sorry.
Yeah, Blue Canyon is.
Blue Canyon is like I have from everyone that has used it that I have heard, they have always said works like a charm. Like
yeah.
at least the ADCS system. About the other systems that they offered, I don't know, but ADCS
yeah,
always.
It was the first company who actually like even was able to provide actually working attitude systems. We flew with the first satellite attitude system, which was the first in their kind of generation from Berlin Space Technologies, and it was a nightmare. So it was actually not working finally. We were able, however, detumble after updating the software and getting a lot of bugs ironed out, because they were only providing the software in the scrambled and coded package, and then having this to the satellite, and then it was a memory problem there and whatnot, and it was like totally crazy. Software is a thing which we are like making more and more and more just software. It's actually having the satellite software itself is already like a big project. So we were just crazy to start like build everything and program everything. But yes, software takes time, but it is not easily visible in the project. So you have like one hardware model, next hardware model. It's very easy to say like, yeah, done, excellent, radio is here, let's do it. But then the radio is actually not working because of the software issues, and then the ironing out the software issues might give like forever. Testing. It's really good to have like scheduled tests for things. And also reviews, although we are not making much reviews anymore because they are annoying, they are difficult, and the same tends to happen with testing. But tests are not only good for testing, but they are good milestones. Like the team knows, like, all right, we have a test, everybody have to make the documentation ready, it's going to be reviewed, and we have to like get like everything connected, it should work, you need to do this, we need to do that, and then it's a very sort of tangible deadline that we have to go to the test. We have already paid like 5,000 for having this vibration bench there. Guys, let's get it integrated, and then you have it. Because deadlines are really healthy. You had a question?
I was kind of interested, when you say reviews are difficult and tedious, maybe give us some more detail on what an actual review looks like. Like, let's say a test passes or fails.
Okay.
What is that
so
process?
Reviews are, there are basically two types of reviews in the space industry. So like ESA types of reviews, our documentation reviews, and then you have NASA types of reviews, which are more milestone reviews with a presentation. How we did our first reviews is that you make the review entirely based on the documentation. You prepare the stack of documentation, deliver it to the review team from outside of the house, and say like, you have 4 weeks or 2 weeks to review the documentation, read it through, give the comments, and then you come to our premises, we have a panel, and you will ask your questions from the team. And then about every question or every problem you are having, we make a table which is called review item discrepancy list, which is like a lot of issues there which you have to answer them. And it takes a huge amount of work to do, and then you have an entire day and they go through like one small item after a small item, and then you have the delta review and the review how these kind of how these things have been like mitigated, what kind of solutions we have here. And then after these solutions are done, you are getting either pass or fail, or typically if you are in the project, you sort of cannot fail, you can have another delta, and then you somehow need to like go forward with the project as well. NASA review is usually sort of simpler. You're setting the goals more sort of easily, like we need to have this one communicating with this one, and now we have a presentation. I will tell you how it is done. We have a panel here, they watch the presentation and say like, okay, how did you do this or that? And then you will give the answers, and then it's sort of more faster done. I think NASA has the documentation reviews as well in a long format, but yeah, having this full documentation review is really heavy. It's like really heavy.
On everyone, by the way, not only on the team that is giving out the review, but also on the reviewers. And that's the problem actually, at least what we have received in the last years when we tried to do this again. The reviewers don't have time anymore for this kind of big stack reviewing things.
And another problem is that if there is something missing from the documentation, like we were missing entire software from the documentation, and we were not getting any questions about the documentation or the software because it was not there.
Sure.
So keeping the scope, general scope, is very difficult. People go into the very details in some areas and totally forget other areas. So you are not like always getting a sort of desired good output from the review in this way.
So
you get a lot of work.
Sounds like a lot of effort and then not a lot of return. But sometimes you need the whole system review. Is that something like when we're much further down the line and have maybe a flat sat or early qualification model,
so
can we reach out for like a system level review?
Yeah. What I recommend I think what is the good way of doing this, you define the goals which are having a lot of sub-goals sort of by default, by design inside. For example, you just like define the goal that we should be able to send the commands over the radio to the camera and receive one picture. Very easily can be this kind of goal defined, but it might be really difficult to actually achieve. Your radio protocol should work, your radio should work, your power should work, everything. Radio should be connected to the camera or the onboard computer and camera. The whole stack of in between needs to work somehow. And even if you are bootstrapping some kind of like MacGyver tape things in between, it still needs to work. And then you are learning the whole chain and the whole process. Sort of like having reviews is like about easily definable goals, and then evaluating how it was done, what's actually in there, and documenting sort of what needs to be done next. For example, you are like bootstrapping something like ugly on the background, then you put it to your Trello that we have to solve this one. And at some point we need to come back to this one. Maybe our configuration system was like, we were just hard coding some of the parameters there, but we need to have a configuration system where we can change these parameters, retrieve and push these parameters. So it needs to be done at some point. So you put it to the list. And if you have this Trello list, you can have like on the left side things which are not living very fast. They can be for years there, but usually you don't want to have a longer project than a couple of years with students, because everybody, like after 2-3 years, you have all the new students, and then keeping the information in the system is really challenging. So what we do here is I'm trying to keep the students in the project. They start from bachelor's, they are somehow connected to the project, go through the masters, and in the best case continue to the like doctoral studies, and then that means like altogether they are like 5 years in the house, and then they know the system, they know the lab, they know like about certain subsystem, many things, and then it is possible. But if you have like totally new batch of master students every year, it would be absolutely impossible to do things like that. Then it needs to be short projects, well-defined goals, maybe only reconfiguring the software, the like hardware is existing or there is coming from somewhere else, and you do like really fast things. Right, but this is pretty much I had in mind in here. You probably know about CubeSats a lot already. You know about the frequency licenses, you know about how to get the launch, you know that for the launch you need also the vibration test. This is pretty much the only thing you actually need. Yes. Any questions or discussion about these topics?
In terms of team structure, I've noticed that here it's very non-hierarchical. So, what is there a specific structure of like teams you would recommend, or like? I know you talked about like having each like subsystem be a separate team, but in terms of like the hierarchy, would you recommend creating one? Would you do like it? Like how do you?
Yeah, I think this is a cultural thing, a culture dependent thing as well. The hierarchy just doesn't work here in Finland. and sort of, I can tell people that you have to do this for the next time. They still might not do it. So I need to also use different other, I mean it needs to be fun and needs to be motivating to do these things after all. Now we are losing this one as well.
Yeah, it seems so. But I think there's two things. So one is like hierarchical in a sense of like someone is telling you what to do, and the other thing is more hierarchical in a sense of information flow. And I think in the information flow, like where you have like a subsystem lead or a subsystem specialized person is telling the system engineer, and then the system engineer is distributing it to the other people, the knowledge that they need to know. I think that is sort of necessary. This is sort of, I think that in that sense the information flow hierarchy, yes, so, there is one, but maybe not in like in sort of like a team structure.
I would say what do you need to have, definitely. This is not the hierarchy. If you have a task or responsibility, it has to be a name there.
Yeah.
So somebody who's responsible for something. But we have been very much assigning people according to their skills. So if you know something about radios, take a look on this one. We put you on the task. You don't need to be the head of the radio team or something like this. It's also, we don't have enough people to, let's say, populate the proper hierarchy. That means like people are acting as a, let's say, cleaning personnel and CEO at the same time. So it's like a small company.
Yeah, sometimes they have a lot of heads.
Yes.
And
in 1 minute I have this head and on, and then in the next one I have a different one.
Yes, and we have the multiple hat situation as well, and we've been running into some problems with some certain team members just not knowing who to go to out of us three when something comes up, or like that's kind of what I mean about hierarchical, where it's like someone doesn't know what task they need to do, and then they like go to Eric when they should have gone to Jake. Or something like that. That's like some situations like that.
But that's like that's something. Even if you have a hierarchy, you will have people that ask the wrong persons. I mean,
but it's more how do we communicate best that like structure, information flow. How do you build that structure?
Yeah, it's tricky. I think what we have, you have to have still one person who is the owner of the project. So the end of the day, things flow to my table. Like if there is like, nobody has been working with the ground station at all, then it starts to be my work. So, and what we try to do is keeping as many information channels open in the project. And I think the most important information channel in our project is actually the lab. People are going to the lab, discussing with each other in the lab.
Alkaa luento.
Yeah.